Okay, class, let's get started for today. Today we're talking about solid figures. Now, we all have an idea of what solid figures are, but to be more specific, a solid figure is a three-dimensional figure, plain and simple, three-dimensional figure. Anything that we can animately touch is a solid figure. Now, as far as from a geometric standpoint, we're going to be talking about a polyhedron. Polyhedron is a three-dimensional figure whose surfaces are polygons. Each polygon of a polyhedron is a face. The line segment at which two faces intersect is an edge, and the point where three or more edges intersect is a vertex. Now, some of these words may sound a little familiar to you when we discussed polygons in previous lessons. Well, let's actually look at them. Here are two types of polyhedrons. They're not the two only types, the two basic types that we will be looking at in our class. We have a prism and a pyramid. Now, the difference between the two, they are identified by their bases. The two bases are congruent polygons in parallel planes if it is a prism. Now, what are we referring to? If we look at this base, let me change it. Here is a base, and this. Notice that those are two polygons that are the same shape, and they are parallel to each other. In this hexagonal prism, we have these two bases. They, once again, are the same shape, and they are parallel. One of our most common prisms that we've looked at is a box. Now, a box can be a prism in so many different ways. We could be looking at these two sides as our bases. We could look here at, let me number these. This could be our bases, base 1 and base 2. We're looking at the top and the bottom, 3 and 4. We have those two bases. And also, if we look at the front and the back, those are bases as well. So a prism is very special. And to be even more special, we have what is called a cube. A cube is a prism, and a cube is a prism whose all sides are all the same, and they are squares. But a pyramid, what about the pyramid? Well, a pyramid is a polyhedron that has only one base, and all the other sides intersect at a point, vertex. And that's the difference between a prism and a pyramid. So we have two types of polyhedrons, a prism and a pyramid, where a prism, the two bases are congruent parallel sides, or they're parallel planes, sorry. A pyramid only has one base, and all the other faces, the sides or faces, intersect at that one point right there. What about non-polyhedrons? Well, we see those in everyday life as well. Here are three of our basic examples. We know that any three-dimensional object is a solid figure, but when we're talking about non-polyhedrons, we're going to be referring to a sphere, cone, and cylinder. And those are the three basic types that we're going to be looking at. Now, when we think of a sphere, we probably think of a ball. We look at a cone, well, just that. Think of a cone for an ice cream. Even though that it may be cold outside, you can still think of an ice cream cone. I'm not getting my marker to right today. And lastly, a cylinder. I always think of soup can when I think of a cylinder. Now, they are all non-polyhedron for the simple fact that they have curved surfaces. Some of their surfaces are not polygons. In this case, we can look at them and we can see that all of these are not polygons. However, if we were able to draw it out maybe as a net, when we are able to make a three-dimensional object into a two-dimensional surface, we could see that a cylinder would have a net that would be two circles on a rectangle. We could not draw as easily for a sphere or a cone would look something like a rounded shape, a circular base as well. And that's what a net is. Now if we want to go back and we want to talk about nets for polyhedrons, let's slide right back up and let's look at that. Now remember, a net is a two-dimensional picture of a three-dimensional object. So a net, let's think of a rectangular prism. That's what this is called. It is a box. It would look something of this nature. There's the front. This could be the bottom. Notice that we're going to draw another one. And these two would be congruent. Numbering those. Oops, let's back up. These two here would be congruent. And then we would have the two end pieces. And that's what a net would look like. These could represent our two ends and so forth. A net is just a three-dimensional object laid out into a two-dimensional form. We can take a three-dimensional picture and lay it flat like a sheet of paper. So, moving on. What if we needed to sketch a polyhedron? I find that a lot of students have difficulty drawing polyhedrons. Now me, with this computer program, I have the ability to wonderfully pull out some nice little pretty shapes, and I could draw those such as that. We don't always have that, because I'm just going by our two instructions here. It says to draw two bases. Well, there's my two bases. Connect the corresponding vertices with lines. Okay, well, looky there. That essentially is a polyhedron. It's not always nice and neat. But let's look at it from this standpoint. Let's look at a cube. Well, we draw the two bases, and they are going to be parallelograms. I'm going to draw the front. Notice that this base is hidden, means it's in the background. So it's going to be represented as dashed lines. And we have that one vertical piece there. So I have the two bases here and here. And then the vertices are connected with vertical lines. So let's get rid of these two. If we could. Let's try to do it all over again. Let's try to do something a little different. Let's say that we're trying to draw another type of prism. What about a rectangular prism? Well, once again, I'm going to use it as a parallelogram and give it a slant. Another parallelogram, where they should be very close, if not the same. And I give it the vertical lines. Give it those broken lines to make it appear in the background. Now, if you mess up and you draw them solid, just go back and erase where it appears that they are dashed. And that is how we sketch a polyhedron. And then let's talk about Euler's formula. Leonhard Euler proved that the number of faces, vertices, and edges of a polyhedron are related by the following formula. He found out that if you take the number of faces plus the number of vertices, that should equal the number of edges plus 2. So we have a cube here. Now a cube, as we can see, has 1, 2, 3, 4, the front being 5, the back being 6. So it has 6 faces. And if we can count the line segments, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. We want to be able to use this formula to find out how many vertices this cube has. So let's use our formula. We have F plus V equals E plus 2. Well, we have 6 faces, 12 edges. Now, simply solve the equation for V. So we have V plus 6, or 6 plus V, if we want to leave it, equals 14. Across. So V equals 8. So based upon Euler's formula, there should be 8 vertices for this polyhedron. Well, let's see if we can count them. There's 1, 2, 3, 4, 5, 6, 7, 8. And there, that is proof. We will use this later on in our classes. I hope that you are able to comprehend the different parts of polyhedrons and to identify the different types of polyhedrons, as well as identifying those items that are non-polyhedrons, such as a cone and a sphere and a cylinder. Hope you have a wonderful afternoon. Hope to see you in class.